In this video, we briefly introduce a spin-decoupled anisotropic metasurface with chirality-assisted amplitude modulation for a low-sidelobe dual circularly polarized transmitarray. The related work can be found in IEEE transactions on antennas and propagation. Spin-decoupled metasurfaces are typically based on anisotropic metaatoms that can independently control X and Y polarized waves. After introducing PB phase from element rotation, two CP waves can be decoupled. Recent studies further demonstrated decoupling of all CP transmission channels, as well as the two copolarized CP transmission channels. An important application of spin-decoupled metasurfaces is the dual CP transmitarrays, where independent phase responses allow different beam directions for two CP waves. However, without amplitude modulation, obvious side lobes are usually observed. Therefore, an important question is whether amplitude modulation can be introduced into the two CP channels to suppress side lobes. However, two main challenges must be addressed. First, conventional anisotropic metaatoms only rely on dimension tuning and element rotation, and lack an additional degree of freedom for amplitude control. Second, most transmissive metaatoms suffer from narrow bandwidth, which limits their transmitarray applications. In this work, we first propose a multilayered metaatom with additional air and metallic layers based on homogenized model analysis. The proposed Model 3 significantly reduces the required admittance range, allowing full phase modulation with a simple structure. In addition, Model 3 provides the widest bandwidth, higher transmittance, and more stable phase response with the smallest dispersion. On the other hand, an interior rotation strategy is developed to realize chirality-assisted amplitude modulation. By reversely rotating the patches on the two sides, the amplitudes of the two cross-polarized transmission channels can be continuously tuned from 1 to 0. Then, by combining interior rotation with exterior rotation and dimension tuning, joint amplitude phase modulation is achieved in spin-decoupled metasurfaces. Based on this strategy, multilayered anisotropic metaatoms are designed, achieving broadband 4-bit propagation phase modulation with high efficiency. By controlling the exterior and interior rotation angles, PB phase modulation and continuous amplitude modulation can be independently realized. Finally, the spin-decoupled metasurface and the dual CP transmitarray are fabricated and verified. After applying the proposed amplitude modulation, the side lobe level is reduced by about 6.3 dB, while broadband performance and high aperture efficiency are well maintained. More details of the work can be found in the paper. Thank you for your attention.